Okay, so for this next video, we're going to look at a different way of dividing two polynomials named synthetic division. And the appeal of this method is that this is shorter than polynomial division. So we're going to have to distinguish between different cases. And the first case that we will look at is the case of monic linear divisors. So what does that mean? Well, it means that the divisor d of x has to be of the form x minus some constant a, where a can be positive or negative. So linear in this context means the degree of d should be 1. So it's x plus or minus something. And monic means that the coefficient of x is 1. And later on we'll see what you have to do if the polynomial that you're dividing by is not linear or is not monic. We're going to explain how this works based on an example, and for the example we'll use the same polynomial as what we had on the previous slide. So 3x to the power 4, x to the 3 plus 2x squared minus 2x minus 1, and the divisor is x plus 2. So as the first step, we will write down all of the coefficients of the polynomial. So let me write the numbers in colors. So write down the coefficients of p of x, that is. So we get 3 minus 1, 2 minus 2 minus 1. Here it's important if one of the coefficients is 0, because the term is 0, then you also have to write down that 0 in this list. And now for the second step, we're going to negate d of x. So we take minus d of x, and in this case this gives us minus x minus 2. And we're going to write down all the coefficients of minus d of x except the first. So all of the coefficients of minus d of x except the first, so that's only this minus 2, and we write that down on the left here. And now you might wonder, well, why do you write down, why do you make it so complicated? Why don't you just say write down minus 2 or write down a? It's because when we look at dividing by a nonlinear polynomial, then we will have to write down all of the coefficients, so there's more than one. And by doing things in this way, we can already make it a bit more future-proof. For the next step, number 3, we're going to lower the first coefficient. So that means taking that 3 that we have in the table here and lowering it down and writing it down here. And then next step 4, we're going to multiply. So in this case, that means taking the minus 2 and the 3 and multiplying them together and putting the result back in the table to have minus 2 times 3 is minus 6. Step 5, we're going to take the two coefficients that we have in our table and add them together. So in this case, that means taking the -1, the -6, and adding them together to get -7. And now that we've done all of that, the next step is basically repeat this until the whole table is full. So repeat steps 4 and 5 until done. So let's see how that works. In the next step, we take the -2 and the -7, we multiply those together to get 14. We add them together to get 16. Then we take -2, and so we write this here. Then we take -2 times 16, that's -32. We add the two coefficients together, -34. -2 times -34 is 68. Adding them together is 67. And if you're very careful, you'll notice here already the coefficients of the quotient and the remainder that we had from polynomial division. So we're done with our synthetic division. Now we just have to extract what the quotient is and the remainder. So that's the last step. Determine the coefficient, or determine the quotient and the remainder. And for monic linear polynomials, there's a very easy rule. So you know the degree of the remainder has to be less than the degree of the divisor. The degree of the divisor is 1, so the degree of the remainder is 0, and in other words, r of x is a constant. So what does that mean for our table? It means that the remainder is a constant, and that constant is always the last term that you have here. So this is the remainder r of x, and here you have to be careful. This is the case if divisor monic linear. And then the remaining terms that we have here are the coefficients of the quotient, q of x. And how do you reconstruct the quotient? You just take the coefficients, 3, and then you put basically x's next to them. So let's write down the coefficients first. 3 minus 7, 16 minus 34. And this is the constant term, this is the x term, this is the x squared term, and this is the x cubed term. So we get 3 times x cubed minus 7x squared plus 16x minus 34. And if you check with the polynomial long division, you have the same result. So let's do an extra example of this just to see some different numbers in action. If you already understand synthetic division and if you're comfortable with this, you can skip the rest of this video. If not, if you want to see another example worked out, then please follow along. So for this example, we'll take p of x equal to x cubed minus 12x squared minus 42, and the divisor is x minus 3. So as the first step, we write down all of our coefficients. So that's 1 minus 12. There's no x term, so that's 0 times x. So we have a 0 here for x, minus 42. The second step is you take d of x and you take the negative of that. So minus d of x is minus x plus 3. And you take that constant term and you write the 3 here. And then the algorithm in action. So we lower the first term, first coefficient 1, we multiply 3, we add together minus 9, we multiply minus 18, we add minus 18, we multiply, and we get, oh sorry, this should be minus 27, minus 27, we multiply, we get minus 81, and we add to get minus 123. And now we have to determine the remainder. So remember, for if we divide by monic linear polynomial, the remainder is always this last term. So r of x is minus 123. And then the quotient is given by the other coefficients. So it's x squared minus 9x minus 27. So, and just to wrap up, what are we trying to do here? So here we have written p of x divided by d of x as the quotient plus the remainder divided by the divisor.